The following is the details and objectives of various technologies are being developed and applied in the Common Rail engine, which is an electronic-controlled diesel engine for increased torque and power, faster response, and high fuel efficiency. The main components of the Common Rail engine are ECU, high-pressure pump, common rail, and injector. We will now learn about the roles of each component. The high-pressure pump pressurizes the fuel into high pressure and sends the fuel to the common rail. The common rail stores the high-pressure fuel received from the high-pressure pump and maintains stable pressure. The injector injects the fuel stored in the common rail into the cylinder according to the ECU signal. The ECU considers various conditions and calculates the injection amount required by the engine. The fuel system in a diesel engine sends fuel from the fuel tank to the combustion chamber and optimally controls the fuel pressure, injection volume, and injection timing according to the driving condition. In the past, various technologies are being developed and the fuel system in a diesel engine sends fuel from the fuel tank to the combustion chamber and optimally controls the fuel pressure, injection volume, and injection timing according to the driving condition. In the past, the fuel injection pump that generates high-pressure fuel via its mechanical structure was used. But these days, CRDI that allows more precision control is used to increase engine performance and satisfy the emission regulations that are increasingly becoming stricter. The CRDI engine uses a fuel system that stores high-pressure fuel in common rail and then directly injects the fuel into the cylinder through the injectors. Fuel flow in the low-pressure line is mainly divided into two types. The feeding type uses an electric low-pressure fuel pump in the fuel tank to deliver fuel to the high-pressure pump. Positive pressure is generated in the low-pressure fuel line. The suction type uses a mechanical low-pressure pump integrated with the high-pressure pump to suck in the fuel. Negative pressure is generated in the low-pressure fuel line. Note that the mechanical low-pressure pump has a priming pump installed on the fuel filter for air bleeding. In the high-pressure line, the pressure of the supplied fuel is increased to approximately 250 to 1,800 bar by the operation of the high-pressure pump. Then, the pressurized fuel passes through the common rail and gets injected into the combustion chamber by the injectors. At this point, the ECU controls the pressure control valves on the pump and the rail according to the vehicle conditions and driver's intention, ensuring optimum fuel injection. The ECU input-output factors in a common rail engine are similar to a gasoline engine. However, unlike a gasoline engine, a common rail engine is equipped with a boost pressure sensor for VGT control, a differential pressure sensor for DPF control, and an air control valve and a swirl control valve to increase power output and reduce emission. In addition, an airflow sensor and lambda sensor are also applied for EGR control. Lastly, an exhaust pressure control valve and a differential pressure sensor are added for Euro 5 LP EGR system control. Let's now learn more about each of these components. The ECU input-output factors in a common rail engine. Let's now learn more about each of these components. The EGR system reduces NOx by controlling the amount of EGR gas. NOx formation can be suppressed by lowering the combustion temperature. The main components of the EGR system include the EGR valve that supplies combusted gas to the intake based on ECU control, the EGR cooler that cools the recirculated exhaust gas, and the bypass valve that directly sends exhaust gas to the intake without passing through the cooler during cold conditions. The post-processing system for exhaust is the DOC and the DPF. The DOC converts some of the harmful substances in exhaust gas into harmless substances. The DPF collects particulate matter in exhaust gas through a filter. When particulate matter are accumulated, the DPF burns them off through a regeneration process.